I did a review of this UNI-T 3305S linear power supply in a previous video, and I've been using it for a month now. It's my favorite bench power supply. Now I'm keeping my test leads attached to it for whenever I need to power something at the workbench. And as that review video was too long, I could not include the teardown in there as well. And in my opinion, teardowns are important for this type of instruments, because even if you just consider the curiosity for tech, but not limited to that, it also helps people make an educated choice of whether an instrument like this is worth purchasing or not. So in this video, we'll do a full teardown of this PSU unit. So let's get this down to bench level and start the teardown. I'm gonna start by removing the rubber bumpers. These won't be going back on because I don't really need them. They're mostly in my way. Then there are a bunch of screws that we need to take out to gain access to the inside. And look at this nice attention to detail. The screws have Loctite on them. And now I believe there are a few screws to take out to be able to slide this metal cover off. But before we continue, let me introduce a new sponsor, Our PCB, which is a professional PCB manufacturer that can offer PCB manufacturing, component procurement, PCB assembly, as well as custom cable assembly manufacturing. They're currently running a special offer, $1 for 5 PCB assemblies, but the order must be placed using a company account. I'm going to be testing their service and revealing the results in a future video. If you're interested in this, check out their website, link below, ourpcb.com. Yep, so it just slides out now. Gonna be careful not to snatch in any of the wiring. And we're in. Just a couple of notes that I'd like to make right now before continuing with the teardown, because I do want to take it further apart so that we can take a closer look at the electronics. But a few things that stand out: massive toroidal transformer and not so massive heatsink. But this toroidal transformer with multiple taps and having some relays in there will go into a pre-regulator before the linear regulator, so it won't have to dissipate as much power into the heatsink. Hence, we don't need such a big heatsink inside this unit. But man, the toroidal transformer is huge, and it has a date code on it of it's July 2023. So yeah, it was built last year. And now if you're looking at the way the toroidal transformer is installed to the bottom of the chassis with that really big mounting bracket and the screw going through the middle, you might think, hey, there's a shorted turn on this transformer, but actually not, because let me zoom in there. I'm not sure if this is showing up on camera, but there's actually some insulating rubber washers. So the screw going through the middle, which also has Loctite, by the way, on the thread, is actually insulated and does not create an electrical connection through the middle of the transformer. So again, nice attention to detail. Now let's take this thing further apart. Alright, so now I have it all opened up and ready for inspection. I have disconnected some wiring, and I have the back I/O panel as a separate module. We have the main power module with the main body of the PSU, which includes the toroidal transformer, and we also have the front panel, and we'll go through these one by one in more detail, but I want to start with a few basic things. We have the mains IEC input connector together with a voltage selection switch on the back panel, and this goes partly through the on-off switch, which completely cuts power to the input of the transformer. The on-off switch module PCB also contains filtering and protection devices like varistors, capacitors, and the power resistor, which makes me think it has some form of slow start circuit implemented. Earth is connected to the metal chassis with a screw right here with a proper lock washer, and again at this point for the front panel, they're not just relying on the different metal parts of the enclosure to carry that earth connection. So all in all, wiring looks very nice and tidy, pretty much what you would expect from a high quality instrument. We have extra sleeving on these wires from the transformer for extra protection. We have these locking connectors all around, so it's going to be easy to disassemble and service, as well as reliable. The PCBs they use in here look to be of very high quality. It's this matte green solder mask finish. And let me tell you something about matte green FR4 PCB. I've been designing PCBs for more than 15 years and I have not seen a bad quality PCB done in a matte color solder mask, because that's always a more expensive option, always done on the better production line at the factory. Not much to say about the transformer other than being a huge toroidal transformer with multiple input taps and output taps which allow for pre-regulation. This makes the final linear regulator very efficient, having to drop less voltage and use a smaller heatsink. And to be very clear, this pre-regulation, there isn't a switching pre-regulator like other designs use. It's purely voltage selection from the different output taps via relays, and then these feed into a pure linear regulation stage. Hence they can get away with this small heatsink and have the output noise so low because there's no switching. The transformer itself is mounted very nicely on this solid bracket. There is a thick screw going through the middle, but it has rubber insulating washers on both ends and Loctite on its thread, so it's not going anywhere and it's not creating a short circuit through the middle of this toroidal transformer. The cooling fan looks to be a 4-pin version, meaning it has the tachometer signal plus a PWM control signal, so it can both report its RPM and offer control over the RPM to the system. And as I mentioned in the review video, it's really quiet. The I/O panel connects to the front panel through this shielded flat flex, which again is nice attention to detail. And this basically holds all of the I/O the PSU offers in this very compact module, and it's driven directly by the front panel where the brain is. This down here is our power stage module, and this takes input from the different transformer taps via these thick wires, and it looks like we have two identical sides, which I'm going to assume are two fully spec'd independent channels, channel 1 and channel 2, plus there are an additional 2 circuits in this area down here, and I'll try to get a different view of this. There are 2 additional bridge rectifiers in here, which I'm going to assume are for channel 3 and channel 4, which have lower specs. Now channel 4 is just a 5 volts 2 amp USB output, and that's probably driven simply from a linear regulator. It may have like a separate voltage tap that's only slightly above something like 7 volts. There are also a number of 3 relays per channel to do the input voltage transformer tap selection. And there are a number of soldered in fuses around this PCB, which is not great for repairability, but I'm guessing those have a trip value above the electronic protection measure, so I'm guessing they should not fail anytime soon and are there just to protect in case of catastrophic failure. This power stage module is controlled directly by the front panel via this multi-pin ribbon cable. And so far I'm liking the modularity and the build quality I'm seeing. I mean, even the metal chassis is spotless, looks like high quality metal with excellent assembly quality. And now moving to the front panel, it gets the output voltage from the power module through these sets of wires, and they go into the PCB. And then here's something that catches my eye. We have shunt resistors near each set of wires, a second set of shunt resistors on the front panel, and they're probably monitoring the input of the linear stage and the actual output to the load as well. That might have something to do with the reaction time, or it might improve regulation. I'm not sure, but it's clearly a sophisticated design which they did in-house. The smaller value capacitors that we have here are Fujikon, while the bigger value ones from the power module are from Macon. And although it's the first time I'm hearing about Macon, it seems that they're pretty big with 70 years of experience according to their website, so I think we're good on the capacitor choice, and also they're all 105 degrees C rated. But here's something that I don't like. This is a voltage regulator which is basically resting on this electrolytic capacitor. That's something that as a PCB designer I would not do, because the regulator is obviously going to heat up and decrease the lifespan or reliability of this electrolytic capacitor. All of the relays are from Hongfa, which is this lower cost manufacturer, but still a big known one. You will find the relays in many of the appliances in your home right now. And I like the way the banana connectors have these screws that go through the PCB into the banana connectors. Makes for a very strong assembly. Now I would very much like to take this further apart to check out the other side of this PCB to find maybe the controller they use, the ADC, because I'm guessing there is a different ADC used between the lower spec 10 millivolt version of the power supply and this 1 millivolt resolution version, which is the higher spec that I have here. So there's nothing actually on the other side of this PCB. It's a single-sided load, which means that our controller must be right on the backside of this cover with the LCD. Finally, we get access to the actual brains of this thing, the microcontroller driving everything in here. We'll take a closer look at that in a second. This is an STM32H750, and this is a beast Cortex M7 with double precision floating point unit. It can run up to 480 MHz with built-in LCD TFT controller. It has JPEG encoding and decoding built in. It's got CAN FD, it's got USB, Ethernet, 12-bit DAC and 16-bit ADC. It's got loads of timers and everything else you would want. But I'm pretty sure they're not using the built-in ADC and DAC combo. They must be using something better externally. And next to it we have the Ethernet PHY. This is a chip which can do 10 to 100 megabits from TI/National Semiconductors, which they acquired in 2011. There is no other important circuitry in here. It's obviously the keypad and the LCD on the other side. So we have to move back to the big and crowded front panel board. And now if we do take a closer look at this board, we're going to notice something interesting. We find three sets of ADC/DAC chips. I'm going to assume that these three handle the three main adjustable channels of the power supply. The ADC is part number ADS1118 from TI, and this is a chip that can do 16-bit, 4 single-ended channels or 2 differential channels, 860 samples per second, delta sigma with integrated voltage reference, temp sensor, and a programmable gain amplifier. The DAC is part number DAC 8562. This is a dual channel 16-bit, again with internal voltage reference. And then if we look around, there's just a bunch of analog circuitry all around these guys. Lots of op-amps scattered around this board. These are all part of the different voltage/current control loops for the individual channels. Plus we get some extra relays in here, these three ones. I presume these take care of the series/parallel connection modes. There's also lots of optocoupler action here towards the top. This is presumably for the ribbon cable going to the going back to the power module. So all control signals are isolated through these optocouplers. I'm going to say this again. It's quite a sophisticated design, which is probably needed for this level of performance and quality. So that's pretty much all that's happening here. I'm going to put everything back together, and I'm going to give you my final thoughts in a few seconds. Oh, and by the way, I don't know if I mentioned this, but the soldering, the PCB, and generally the assembly quality on this board is top notch. Now, you already know my thoughts from the review video. There's nothing like it on the market that sells for the same cost in terms of precision, accuracy, build quality, etc. And after seeing how this thing is built inside, then this can only confirm what we've been noticing in the review video. This is a top class instrument, both in terms of performance and actual build quality. But what do you think? Do you have another brand of power supply? How is yours built? Does it look as nice as this one inside? Let me know in the comments below, and I'm pretty sure that the lower spec models from the same power supply class are built with the same quality. But anyway, let me know in the comments below what you think. That was all for today. Make sure to subscribe to the channel for more content ahead. Thank you for joining me, and I'll catch you in the next video.